And good morning, math wizards. Welcome to yet another edition of Mr. Lega's Eureka Math in the Morning. We're doing today problem set from lesson 12, module 4, lesson 12. I'm doing it on a piece of plain white paper because it's pretty hard to see the tiny little writing on our problem sets. So just follow along with me. Once again, it's problem set lesson 12 of module 4. If you didn't rip this out, if you weren't there Friday, you can follow along with a blank piece of paper like I'm doing. So we're looking at number 1. It says each side on a sticky note measures 9 centimeters. What is the area of the sticky note? Okay, this is something a little different. There's our sticky note. And this doesn't quite equal 9, but let's pretend it does. All right, because normally we've been working with rectangles that have a different side and a different length, different width and a different length, but a square has the same. So we're going to put 9 centimeters, and you don't have to have a sticky note, you can just draw one, and 9 centimeters. Well, what would 9 centimeters, what would the area be in here? Remember, area is not about addition, it's about multiplication. We multiply the width and the length. In this case of a square, just the two sides are all we need. They're all 9 centimeters. We just need to multiply 2 of them. So we would say 9 centimeters times 9 centimeters equals what? 9 times 9? Let's figure it out. 9, 18, 27, 35, 42. Excuse me. 9, 18, 27, 36, 45, 54, 63, 72, 81. So it'd be 81 square centimeters. And remember, when we think about square centimeters, just think about it like this. 1, 2, 3, 4, 5, 6, 7, 8, and 9. And then we go down. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Not perfect, but guess how many little squares there are on there? There's 81. We could count them, but no need to count because we just go 9 times 9 is 81. All right, let's continue on with our next question. It says, Stacy tiles the rectangle below using her square pattern block. So I'm going to show you the rectangle Stacy drew because it's really small on your problem set, and you can just follow along. So she has 4, 1, 2, 3, and 4, and 1, 2, and 3. So let's go ahead and make that rectangle. If you have your problem set in front of you, you don't need to. But here we have the rectangle. And it's just square units. They don't tell us it's centimeters. They don't tell us it's feet, yards, meters, whatever. So how many square units are there? Well, there's 3 on this side and 4 here. So all we have to do is 3 times 4 equals 12 square units. And take a look. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We got it. The next question says find the area of Stacy's rectangle in square units, which we did. Then draw and label a different rectangle with whole number side lengths that has the same area. Well, we got to come up with 12 square units, the same area. So let's think about that. 3 times 4 is 12. What else can I multiply to get 12? What if I tried 2? 2 times what equals 12? 2, 4, 6, 8, 10, 12. It looks like 2 times 6. So let's make a rectangle that's 2 units by 6 units. So I'm going to go 1, 2, 3, 4, 5, and 6. And then divide it by 2. Split it in half. So now I have 2 by 1, 2, 3, 4, 5, 6. What's my area? What is the area of my rectangle? Well, all we have to do is 2 times 6. We know that equals 12 square units, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. What else can we do? It says, can you draw another rectangle with different whole number side lengths and have the same area? I bet we can't, don't you think so? What would our other rectangle look like? I think there's one more combination we could do here. I know 3 times 4 equals 12, 2 times 6 equals 12. We could flip it around. 4 times 3 equals 12, 6 times 2 equals 12, flip them around like that. But what else can we do to equal 12? We could try 1, right? 1 times 12 equals 12. And let's make the square units. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So this is 1 by 12, 12 square units. And isn't this a hoot that they all have the same area, yet they're all have different shapes? And we talked about this a little bit yesterday when we find the difference between two sides, and the larger that difference is, the longer the rectangle will go. So there's 3 by 4, and notice 2 by 6 is longer, and they're not to scale, they're not perfect. And then 1 times 12 is long and skinny. Isn't that interesting? I think so. Okay, let's look at the other side of our problem set, if you have the problem set at home. And our question is, an artist paints a 4 by 16 foot mural on a wall. What is the total area of the mural? Use the break apart and distribute strategy. Uh-oh, the phone's ringing. I owe the class a marble. I didn't put it on silent. We're going to do that right now. It says it's from spam risk. I don't even want to get that phone. All right, so let's figure this out. And this is page 98. So we have a mural. It's 4 by 16. But we're going to break this up a little bit. So we have 4 feet and dot, 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 dot. So make it look like that. We're going to label this section 10 feet and this section 6 feet. That's a lot easier to tackle than 4 times 16, I think. Let's do it. So we have 4 times 10 is 40, right? There's 40 square feet. And 4 times 6 is 24. 24 square feet. Well, now all we have to do is add those two together to get the total area of the mural. So we would have 40 plus 24, 0 plus 4 is 4, and 42, 4 plus 2 is 6, or actually 40 plus 20 is 60, so it's 64. So together the mural equals 64 square feet. Remarkable. But now let's use the distributive property to do this as well, okay? So what we would have is 4 times 10 parentheses plus 6. Okay? So 4 times 10 plus 6. Okay? That would equal 4 times 16. But we could break that apart even further with parentheses. Oh, I said the magic word. Parentheses. Here he comes running up right now. Did somebody say parentheses? Yes, I said parentheses. And what do we do with parentheses, math? Well, we always do them first. That's correct. So we got an example here of finding out the square area of a mural. I know I was listening in. Oh, you were spying on me. Well, I like to call it listening in. All right, well, just continue listening in and come back if I make any mistakes, okay? I will do. So we have 4 times 10 plus 6. And now let's break this up even further, because this will just be 4 times 16, and we'll say 4 times 10 plus 4 times 6. And once again, we get the answer right here. 40 plus 24 equals 64. So we know it's 64 square feet, okay? We're going to take a look at another piece of paper. And our next question is question 4. Alana tiles the 3 figures below. She says, I'm making a pattern. Okay, so then we're going to find the area of Alana's 3 figures and explain her pattern. So let's go ahead and see what her pattern looks like first. I'm going to go ahead, because it's so small on Eureka Math that I just don't think you can see it too well until I get my studio up and running. So we have one rectangle that's 4 square units. Okay, the next rectangle we're going to make is a little bit taller. Oops, terrible looking rectangle. And we're going to go 1, 2, 3, and 1, 2, 3. The next one, a little bit taller, a little bit wider. We'll go 1, 2, 3, and 4. 1, 2, 3, and 4. Okay. She says, I'm making a pattern. Do we see a pattern here? I think we do. So it says, find the area of Alana's 3 figures and explain her pattern. Okay, well, let's just label them first. We have 2 by 2, 3 by 3, and 4 by 4. Do we see the pattern there? Yeah, she's just adding 1 on. So what's the area of this one? All we need to do is 2 times 2, not 2 plus 2, but 2 times 2 to get 4 square units. And I'm just going to I'll write units. How about this one? Once again, it's not about adding. We multiply 3 times 3. Well, that would be 9 square units. I gotta get some better pens too. And then 4 times 4. 4, 8, 12, 16. This one will be 16 square units. So, what is her pattern? Well, the pattern is she just adds 1 to each side as she goes from a larger rectangle to a larger rectangle. Now we're going to draw the next 2 figures in Anna's pattern and find their area. So the next one, we did 4 by 4. Let's do what? Well, we would do 5 by 5. 1, 2, 3, 4, and 5, and 1, 2, 3, 4, and 5. So what would that be? We have 5 on this side, 5 on this side, 5 times 5. Remember our hide and go seek video we used to watch all the time? 5, 10, 15, 20, 25, stop. 25 square units. They're square. The next one would be 6 by 6. So let's make 6. 1, 2, 3, 4, 5, and 6. And 1, 2, 3, 4, 5, and 6. So we're going to label those 6, 6 on each side. Now, just like we did here, we did 5 times 5, so now we're going to do 6 by 6. 6, 12, 18, 24, 30, 36. So we have an answer of 36 square units. All right. Got one more problem to go, and thank you so much if you're following along either on the problem set or the paper. But, got to keep you learning through this break, so I appreciate you being here. Problem 5 says, Jermaine glues 3 identical pieces of paper as shown below and makes a square. Find the unknown side length of 1 piece of paper, then find the total area of 2 pieces of paper. Okay, so once again, it's like our Post-it note. And I'm going to put this right here. So we kind of pretended that this was 9 centimeters and this was 9 centimeters. And you could go ahead and draw one. Unless you happen to have a Post-it note handy, you can go ahead and use the Post-it notes if you like. And what it's showing is that our friend Jermaine here is gluing 3 identical pieces of paper together. So let's say that was 1 strip that he glued down and 2 strip, and let's pretend they're identical. Okay, I don't want to sit here and make them all perfect because we got a lot to do. So what the question is asking us is to find the unknown length, I'll make a little bracket here, and you can make that at home, of 1 side. All right, what is that unknown length? Well, we're going to have to do a little division, aren't we? What is 9 divided by 3? Or 3 times what is 9? Remember we always did this? We would say 3 times a number equals 9, or 9 divided by a number equals 3. So, let's think about that. We put it into 3 equal strips, right? So 3 times 3 is 9, 3, 6, 9. And 9 divided into 3 is 3 as well. So we know that this unknown side equals 3 centimeters. Then the question wants us to know, what about the area, the area of in here? What would this area be right here? Okay? Well, think about it. 9 times 3 is what? 9, 18, 27. So this would be 27 square centimeters. What about here? What if we were going to do 2 instead? Let's picture that, okay? What would we do if I wanted to find the area of not just 1, but of 2? Well, I know that this side is 3 centimeters too, right? So I have to add these together. 3 plus 3 is 6. So we do 9 times 6. 9, 18, 27, 36, 45, 54. 54 square centimeters. And we already figured out on problem 1 what the total area of the sticky note is. Here in this case 3 equal strips of paper that happen to equal the same as the sticky note, but that's too much detail. We just go 9 times 369. 9 times 9 is 81 square centimeters. Okay, I hope you enjoyed the lesson today, and be sure when you're done with this to check your social studies for a social studies video on, well, you'll just have to wait and see what it's about.